Hello, everyone. Welcome back to Advent of Code, where I'm teaching myself to play Kotlin live on the dang internet. Yikes. Did I say play Kotlin? Write Kotlin. I reviewed the first batch of videos that I recorded, days 1 through 4, and I realized that you guys weren't able to see any of the stuff in the IDE that wasn't kind of like the main content. You couldn't see when I was clicking through menus. You couldn't see when it was giving me helpful pop-ups like this or autocomplete or whatever. And I found out that, I guess in modern versions of Windows / modern versions of OBS, you can't use window capture to capture pop-ups that are spawned by a window or tooltips or what have you. I think in a Windows sense, those are separate windows if they're not just drawn by the app itself as part of its kind of content. So I hope you guys appreciate the misery I'm going through here. I'm giving you this stuff by switching to display capture, but I only have one monitor and I don't want more because of visual acuity issues. So I'm doing a display capture where I've cropped it to just the part that's Visual Studio Code so you can see everything that's on the screen. But it kind of sucks. Am I crazy? Are you guys actually seeing this? I can't trust myself now because I can't have the OBS preview up except on a tiny little edge of the screen. I can't move the VS Code window or the cropping of the display will be fucked up. It's like living in the Stone Age again, having to work around this tooltip thing. But, for Kotlin and IntelliJ, the feedback from the IDE is pretty important for understanding what's going on. And I thought it was important for you guys to see it. But I'll probably screw up, transitioning between this and other stuff on occasion. So that's life. Anyway, moving on to day 5. This I'm doing not with display capture, of course. I'm doing the normal window capture thing, but you don't really care, I don't think. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. Are we solving Hanabi? Or not Hanabi? Tower of Hanoi? To ensure none of them, the crane operator can rearrange them in a series of steps. After the crates are rearranged, desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. But they have a drawing of the starting stacks and the rearrangement procedure. Okay, so we're not solving Towers of Hanoi. Wow. This is really... You have to parse this? This doesn't look like a lot of fun. Well, how many stacks are there? Anyway, in this example, there are 3 stacks of crates. Stack 1 contains 2. Yeah, okay. Z's on the bottom. Yes, it's all very obvious. The arrangement is procedure. Move. We're grabbing chunks of them and moving them over. Okay. So... a quantity of crates, so 1 crate is moved from 2, that's this D, to 1, so we get the D here. Then 3 crates are moved, and I assume they stay in order? No, they don't. Oh, okay. They're moved 1 at a time. I'm deeply suspicious of that. I imagine part 2 is going to be, actually... they're moved all at once, not 1 at a time. Therefore, you can't just use a bunch of stacks. And then both crates are moved from stack. Yeah, okay. The elves need to know which crate will end up on top of the stack. On top of each stack. Okay, I mean, it seems simple enough. This does not look like a lot of fun to parse, though. Wow. I mean, I guess we can take it as given that there are exactly 9 stacks when we're parsing. And then, like, on each row, there's just sort of 9 chunks of 3 characters you have to look at. They're either all spaces or they're bracket, letter, bracket. Okay. So I imagine we want this to be, well, we want to use a stack here, at least for part 1. The problem is designing a storage format that can easily accommodate part 1 and whatever part 2 is going to be. That we don't bake in too hard all the assumptions from part 1. And I suspect the one that would be most interesting for them to change would be, oh no, they aren't moved one at a time. They're moved all together. So you have to take a chunk of them and move them like in place. So what are like well, okay. I mean, I guess one thing we can do is just copy this and put it into our puzzle input. Yeah, sure, put that in Git. One thing that I'm now realizing is kind of difficult about, I mean, for starters, the fact that I can't even see, I don't have a preview window because I couldn't fit it on the screen along with Visual Studio Code. So I just have to like trust that it's showing you that I'm recording what I think I'm recording. Oh, I think did I forget to switch back to, these are like, I was hitting the wrong button to switch back to Visual Studio Codes. Okay, sorry, you didn't see me paste this. Nothing interesting happened. One thing I'm realizing is that I no longer have, I've said in past years that a person's browser is very personal and intimate, and I don't really want to share anything except specific web pages. Not that I think my browser is super embarrassing. It's just like, oh, see, now already you can like see it because I'm still on the display capture. Oh my god. But like, you know, talking to a search engine, oh, ugh. On camera, no thanks. But now that I don't have like, I can't just switch to OBS and be like, or sorry, switch to Visual Studio Code and say, you guys have to look at this now because it's a display capture. If I put something else up in front of this, you'll see it. So I have to figure out some other plan for doing browser searches. For now, I'll just pause the video for a sec while I look for Kotlin's data structures that are stack-ish. All right, so I just looked around and was very quickly reminded, oh yeah, of course. On the JVM, the way you would represent a stack is as an array double-ended queue, where it's like the same data structure that can be used as a queue or a stack. And from what I could see, that's what people recommend using in Kotlin as well. However, double-ended queue does not, I mean, okay. I envision in the future wanting to take multiple things in the same order from the stack, right? Without, because if you put A, B, C, D, E on the stack, and you say, I want to take 3 things off, you get E, and then D, and then C in that order. And then that's great. If you push those onto another stack in the same order, you get... Oh, well, wait a minute. If I... let me actually just fiddle around in a text file here for a minute. Or I guess in my Kotlin file. So if we had a stack that looked like A, B, C, D, E, and I had another... Yeah, I know, this isn't Kotlin. Give me a break. And we had F, G, H here. If I had this stack and I said, please take off the last element and put it here, I would get E. And then I said, take the last element and put it here, I would get D. And so they come out in this order, E, D, C. They come out backwards, which is exactly what we want for part 1, right? They come out in backwards order, right? Just 3 times, take one element and put it on. But if, as I predict, in part 2, they're going to say, just take all of CDE and put it here, well, you know, array deck, I mean, people say deck, I don't know, it's a double-ended queue, DQ, whatever. Doesn't really have an easy way to say, give me a chunk of 3 elements, right? You can just say 3 times, take an element. And so I was thinking, well, you know, maybe we shouldn't use a stack, or a deck for that matter. Maybe we should just use lists. And, you know, it's not efficient to remove elements from the end of a list, but it's not impossible. And it's not super inefficient, and the efficiency certainly won't matter for this program. There's a small number of stacks, each with a small number of items. We're doing a small number, right? Yeah, we're doing like 500 operations on them. It should not be a big deal. But I'd like to figure out, you know, idiomatically, what are the right data structures to use to solve this if we had a million stacks with a million items each on them or something. And a list is probably not that bad, right? Because, you know, array lists and stuff like that, they just sort of track a capacity. Sorry, they have a capacity, which is like how many elements are allocated. And when necessary, they resize themselves, but they don't resize exactly. They leave a bunch of wiggle room and mark, like, here's where the actual size is, right? So if you add, like, you know, if you add one element at the end of a list, most of the time, an array list, most of the time it's basically free. A small amount of the time it costs a significant amount of work, but it amortizes to be cheap. And I think since we're always working at the end of a list and never doing stuff in the middle, it would probably be fine to use lists to represent this, and indeed probably also be short code. However, it still doesn't really represent, like, conceptually what we're doing, right? Really, conceptually, we're working with stacks, and that's what array deck is for. So I think what we can do, instead of using a list, is we'll use an array deck, and we'll just use one end as, like, the top. And for part 1, we'll say, okay, 3 times move move something here. So do this, do this, do this, right? But then, when we need to implement part 2, we don't have to make any fundamental change. What we can do is just use a temporary stack. We'll say, okay, we want to take 3 things off of here, 3 times, grab something from here, put it onto this empty stack. And then 3 times, or for the size of the temporary stack, which will be the same, of course, grab it from here and put it onto the destination. So there's this intermediate stack we're using to reverse stuff. And now we've moved the CDE using, like, just stacks, which I think kind of makes sense. Right? Because we're like, I mean, I guess, I don't know. It doesn't really represent what we imagine the crane is doing. It's not picking things up. Well, in some sense it is. And putting them back one at a time. In some sense it is, if you squint and visualize it just right. So, the point is, I think we can use an array deck as a stack, and we'll just use a type alias where we call it stack. So all this is delaying the unpleasant part, which is parsing. But that's okay. It's still nice to think through what we're going to do when we're done parsing. So I guess let's, all right, type alias stack of t, I assume I can say that, is array deck. I'm a little suspicious of the one in Kotlin.collections. I know the one in Java util works great, but fine. I'll take your word for it for now that I might want to use this. And we need this type to let us write the signature for like the parsing function, right? So let's write main at first, I guess. Read input for day 5. And honestly, I think we just want to feed this entire list of strings into a single function, right? So let's say val stacks equals parse of this, right? Please give me parse. Input is a list of string, and it returns a list, which we know will have 9 elements, of stack of, I think, char, right? Yes, it must have a body, I understand, but I haven't written it yet. Give me a break. List of stack of char? I mean, I think that's fine. Well, I mean, I guess we're only going to use one kind of char, right? One kind of stack. We might as well just have stacks. Specialize it, why not? And we can say, oh, it's actually more than just a list of stack, isn't it? Because it's also a list of moves. Okay. Well, let's just return null here, and I know that's not allowed, but like, give me a break. Oh, I have to say return. We'll implement this later one day. So let's, for starters, let's define a class holding, oh, I can't alt tab because I'm using display capture. So let's do this first. There we go. So a move is just like a triple of ints, but I don't think we should use triple even though it exists. We should name a type that represents these with named fields. So we have a data class move, which has, I can't believe I'm supposed to say val here, but okay, I know, mutation. Everyone assumes mutation. Is a quantity, which is an int, and a source, which is an int, although maybe, you know, we could have an alias, a type alias for like stack a number. I won't. Val, oops. Yes, you're right, don't capitalize that. Oh, we'll even type out destination. Great. So I guess data class input, which is a val stacks, a list of stack, and val moves, which is a list of move. So this really should actually return an input. we'll have to parse out these stacks and then the moves. Yeah, don't call it stacks. So I guess we need to, there's a few things we need to do here. Val stacks, let's say, is repeat. Idly. How do you what am I trying to ask? How do you execute something multiple times? You know what, maybe I'll do to solve the too intimate search is I'll just do the search in another window and then drag the results in here. Kotlin execute multiple times list. Repeat. There is something called repeat. Oh, but that just like performs side effects. Yeah, that's what I was looking at. Continue n times, repeat string n times. How do you... I mean, this even exists in Java, right? Like n times? Creating collections with repeating elements? Ah, okay. List takes a lambda, I guess? And its constructor? So... that's the kind of thing I should... But I'm looking... Yeah, oh, I want a list of... Okay, got it, yeah. So let's say list size int and then a function to initialize. So I have not. Oh, well, okay, I'll use 9 for now. And the lambda is supposed to be the last, it's supposed to be outside, right? Can I just not write the parameters if I'm planning to ignore it? Oh, I guess what I want to do is say stack of array deck. Yeah. So I think that's allowed, except I want to extract a constant for this. Num stacks. So this looks right. I've said, make me a list containing 9 items, and to initialize each item, just call stack of new array deck, right? Cool. So now I have the 9 things I'm going to work on. And we're going to be building it from the top. Which means we need to use it as a queue, right? So, like, add first, I guess, is what we're doing every time we get a thing? Okay. Let's say val cross section is a regex of what does a can't alt tab. I'll get used to it one of these days. So there's basically we expect to see 9 times Actually, I guess I can look in our input file maybe. Day5.txt. Yeah, and it doesn't end with a trailing new lines or trailing space. So I guess we're looking for like this pattern optionally with a space exactly 9 times. So we can say it's get out of here. We need open. I don't need open parents. I'm not going to use a capturing group here because it's just not the right way to do it, I think. But we want either. Well, okay, I guess whatever. This is the correct way to do it. Either a single character, and I guess we'll say A to Z because these are all labeled like so. Why is this highlighted? Redundant character escape. I guess you're right. You don't have to escape a square bracket outside of... Unnecessary non-capturing group? What do you mean unnecessary? Oh, because I haven't written anything else yet. Sure. So it's either A to Z or... 3 spaces. Yeah, I know. What do you I put 3 spaces in on purpose. What do you think I should do? Fine. There you go. 3 spaces. Are you happy? Followed by an optional space. And all of that exactly 9 times. See, like, look at this garbage. This is why I love Haskell's applicative regex or just writing a real parser. This is horrible, and it's like, it's only really a simple regex, and it's just completely illegible already. I could take out the question colons if I were willing to have the regex engine unnecessarily capture data that I don't want to capture. But it still would be dreadful, wouldn't it? So here we're basically saying it's either... Anyway, and with regex applicative, you can write kind of a program that parses things, and it gets turned into an actual regex, but not this kind of string representation of a regex. This is, I guess this is fine. So this is, you know, whatever. We can say while. You know what we could do? We could just write a regex that recognizes the sections, a regex that recognizes moves, and just have them scan over the input multiple times. Each one scans over all the lines, finds all the lines it recognizes. So let's do that. Val move is regex of move /d from, actually this might be multi-digits. Is that allowed? Yes, 10. The others can't be because there's only 9 stacks, but you could move multiples here. From /d to /d. So, yeah. Maybe... maybe I should split these into 2 functions. No, don't. I was just hitting shift because I'm nervous. Not because I wanted to do something. Not nervous, but fiddling. So like, what we could do is say, just immediately return an input whose stacks are parse stacks of the input, and whose moves are parse moves of the input. This is not like the cleanest approach because it processes the list twice, but it's a lot simpler, I think, than writing a single parser in a language that doesn't like love parsers the way Haskell does. Yeah. Why is it saying it wants to return a list of array deck of char instead of saying it wants to return a list of stack? They're the same type, so it would be correct, but I would have thought it would use the same type alias. Whatever. So then I can just take this part and put it in here, and this part and put it here. You know, now I can say, I hit the fucking insert key again. Probably I can get rid of the explicit type information too. This could go down here. So basically we want to say, take the input and let's say stream it, I guess, and filter it to those items which cross-section dot matches, I guess, the stacks, no, it. And then for each one, we, I think, are just going to write for each here, right? For each ordered, that's important. Well, let's actually not do that just yet. Let's map parse row of it. It is a real string, thank you. And it returns a list of pair of stack number or index to char, I guess. I kind of hate it. So we basically, can I chunks a string? I can, okay. Chunked of 4. Oh yeah, you're right, it. Huh, very funny. I shouldn't call it an it. It's a row, I guess. Chunked is up to 4, right? So on the last one, when there's only 3, it'll still work, right? Can be, the last string may have fewer characters. Okay. And what did I get as a result? A list of char? A list of string. Yes, of course. That makes sense. Well, let's say private const val. I don't know what const even means in Kotlin. We want a regex here that is the I don't know, crate, I guess? How did I end up with caps lock on again? I really, like, my caps lock key is mapped to control. It's impossible for me to turn on caps lock. Except every so often it gets turned on anyway. And I don't know why. Crate. I had to take a second off to sneeze. I'm back. A crate is a regex of, I mean, it's very, very simple here. A to Z. Optional question mark. What? Okay. What is? Okay, you're telling me const. Okay, so you're like, these are whatever. I'll get rid of const. So like, these are supposed to be compile time literals or something. So what I want to do is take the rows and map, flat map indexed, I believe. What's the difference between these? Kotlin collections. Oh, there's for, no? Int string to iterable, int string to sequence. I'll figure it out later, I guess. This is supposed to be like that, right? I'm not supposed to write parens, I think. I just say null here. That like parses but doesn't type check, I assume. Yeah. Okay. That's fine, I think. Flat map indexed. Well, will you write it for me? This index, yeah. We'll just say I comma s though. Crate dot match entire of s. This might return null if it doesn't match, which can actually happen this time. And I want to return null in that case. I'm just going to write the dumb thing, as I usually do, and see if it corrects me. Local match. If match, you say equals null? Is that how you write it in Kotlin? Return null. I know for now it's foldable. I'm not sure what the right way. How would you do this? Oh, right. Because return itself can be part of an expression. Okay, sure. That's what I like that. And then we can say val label equals match dot destructured. Does that work? Because I want it. Do I do this? Is that how I get to the first item? Yeah, now labels a string. Okay. And I should then return a list of a single element. That element being a pair. Probably you write it like this, right? Nope, not that pair. Oh, I probably just write pair like this, you weirdo. Pair of... I'm so used to never using anything as a constructor. I sometimes forget that in Kotlin, that's just like the type's name implicitly has a constructor, and that's how you should make it. List of pair of the int is I plus 1, and the char is label dot char at. Hello, char at. Is this not a string? Okay, I probably am just supposed to write 0 here, actually. If this is a Kotlin string and not a Java string. I'm sure they're really, like, basically the same thing, but this one has different... So, okay, so this... Alright, why don't you like this? Oh, because are we returning the wrong thing here? I have to assign this to a... Well, actually, no. This is what I think I'm finished with this function, and it doesn't type check. If I'm mapping indexed... But what's the type you think I'm using? Is the problem that I'm returning null, actually? I thought that was how sequences represented no such element. Empty sequence? Empty... Well, okay. List of... Empty list? Aha. Okay, that's better. So this all now type checks. And I've basically got a way to parse a row and say which stacks should have what added to them. Actually, I'm adding one here, but I guess I should probably just use have my stacks 0 indexed, and then only in move do I translate which goes from where, right? What's this problem, by the way? Like, I'm just not done writing the program. Ah, well, okay. Oops. There you go. Happy now? Ugh, I hate this. Okay, put it back. There you go. Oh, but this, I didn't... okay. I think you're only supposed to use this equals thing for, like, relatively short bodies. So I really feel like this could use a test, yeah? So let's... I forgot how I get to the REPL. It's around here somewhere. Isn't it? Oh, it went to the top because I've used it before. Yeah, okay. Build it again. That's fine. So let me go... Oh, I don't have to go look at the input. It's already here. Day 5. So what I want is to know how you would parse row of this. Control Enter. Unresolved reference parse row. Okay, screw you. Control Enter. Well, I mean, it could be worse. It didn't throw an exception. We just got an empty list when there clearly should have been some entries. So, great. Let's throw some breakpoints in here. Is it? Well, actually, what even happens if I do this again? Is it actually gonna respect my breakpoints? No. If I say debug, that's a different thing. All right, well, we can change main then to... Actually, let's just run this main, yeah? Debug it. Something's not yet implemented. I agree. But we shouldn't have gotten that far, right? Oh, should it just be this? We're returning the list of stacks here? Variable stacks is never used. Well, that's true. And this is returning completely the wrong thing, so it's mad here. Yeah. I just want, like, to see... Okay. Let's just put that back so I can run it again. That's the cross section. Those are the stacks. Okay, so the problem is that cross section didn't match anything. Why not? They look right to me. All right, here's an example. 1, 2, 3, 4. There's 9 of these. They're each... This is either... there's too many... No? This looks right. But I assume it's not. Well, that certainly explains why we didn't hit any breakpoints inside a parse row. We didn't call it. Because we didn't find any rows that looked like stack setup rows. How do you even debug a regex these days? What if I just copy this and take it to an online, like, regex tester thing? Those exist. Online regex. Actually, does IntelliJ have one? IntelliJ regex tester? Check the regex. Okay, well, it says you can. Regex. Check regex. No, that's a setting. Huh? Oh, okay. No, this is formatting. There was a thing. Oh, the check regex intention on a regular expression? So I should look at this. Nope, that doesn't look right. Well, maybe it doesn't do this because I'm in the middle of debugging. Check regex, here we go. So it should match. I mean, this. It says it does match. Huh. I can put an extra space if I want, but if I put more, it says, no, it doesn't match. That's what I thought. Actually, wait, why is it allowing all this? So we have either a square bracket, a letter, and a square bracket, or 3 spaces. That is optionally followed by a space, and we have that pattern 9 times exactly. So, I mean, that sounds right, and it even, IntelliJ claimed it does match. So, I mean, can I put a breakpoint in here? Somehow? Probably, right? Here. No? This didn't get executed either? Surely input is not empty somehow. We saw that it's not empty. So step into this. What the hell? I'm in filter. Okay, this is not what I wanted. I want to step into like the execution of this lambda. And there's a breakpoint here, but it never gets hit. I want to know what it is, I guess. Print on it. There you go. So there's none. How is this possible? Do I not understand what filter does? Okay, I mean, I can remove the stream call if you want, I guess. Oh, it's because I don't have a collecting operation. I just created the stream, and I'm not actually consuming it, so none of these calls ever happen. I see. If I had finished writing my program, the program would do what I want, but here, I haven't gotten to that point yet. Yeah, so now cross-section.matches, like we can ask, I assume, evaluate this. True. Great. So that actually happens. Okay, get rid of this breakpoint. That's all fine. And now we're in parse row here, which is the thing that actually wasn't working when we tested it at the REPL. Oh, and I can immediately see why not. I put too many backslashes here. Very funny. So get me the... How do I... Where's my... I had a REPL a bit ago. REPL. Build it again. Fine. I don't care. This. What? You deleted my old input? No, it's just... I can't look at my previous input? What a joke. Parse row of... this. Still empty. How dare you? Oh, that's because I didn't select all the way to the end. Okay. This, but without the new... Oh, no, that is the end. Oh. I insisted that there be exactly 9 of them. And this one doesn't... it's not padded with spaces, so it doesn't match. I see. So if I gave it this, it might match. Because there actually are 9. No? You don't like that? This is such bullshit. Okay, there's clearly some bugs. One is we said 9, but really it should be like 0 to 9, right? I think you can just do this. No? 0 to 9? So... I mean, I still want to know why it's wrong. So I guess debug it again. So row is this. String is empty. Yeah, makes sense. Ooh. That's correct. The first entry should have been empty, so we returned empty list. Good. Now we're given... Oh, I didn't put in the capturing group this time. It should be there. Okay, one more time? This destructuring failed, I think, basically, because... Hello? Why are you not running? Because I didn't include the capture group telling it what to destructure, basically. So here, there's nothing that matched. Great. But it still returned and was mad. So R. So why would you not... What is S? It's a string of 4 bytes. The last byte's a space, and the first 3, yeah. So why doesn't... Crate dot match entire of S. Null. But it shouldn't be. Okay, well, I mean, let's ask IntelliJ again, shall we? I've got this regex here. I'd like to check it on the string G. Like, that matches. And I'm pretty sure that's the string that I had, right? Print line of S. So here I assume it printed like an empty-ish string somehow. That's fine. Why? It seemed like it skipped over this completely. Did it though? No, it printed this. It's bracket G bracket and then a space. And that's what this is, which makes sense. I mean, you can look at this bracket, you know, G is the 7th letter, so this should be 6 more than A. I think A is 65, so that all makes sense. Then a close bracket and then a space. But crate.match entire of S clearly returns null for some reason, right? I checked that. Can I just say evaluate this? No. But I've used match entire previously and it's been great. What am I missing here? Kotlin match regex entire. God. Match entire Kotlin programming language. So if I bring this over to you guys so you can see it, takes an input and maybe returns a match result. The entire input character sequence. I have a character sequence of 4 characters. And it should match, but it doesn't. Well, okay. I mean, I guess I can try to narrow things down a little bit by running in the REPL again. It's going to want me to rebuild, of course. No, it doesn't? Okay. But I want to test, like, does regex of... Actually, can I just say crate? Why don't you... Whatever. This regex dot match entire of this. No. Why? Oh, did I forget the... I somehow edited the closing brace, the closing square out of this? Oh my fucking god. I swear it was there before. It probably wasn't. It's on camera. This is what developing is, by the way. If anyone is thinking of taking up a career in software development, don't. It's miserable. Okay. So this failed to match. We expected that. This matched. Oh my god. Label is... What? Oh, I put this inside instead of out. Okay. So now I think this part is fine. And if I were to enter the REPL again, I believe I could successfully build module again. Parse this, let's say. Parse row of this. Yes, we can see that stack 1 should get a G. This is stack 2, but we're zero indexing them, so yeah. 2 should get an R, and 7 should get a P. Perfect. Okay, thank God. So we can throw away all these prints and the breadcrumbs of a shattered mind. Why is this not... I'm a little surprised that when I say to reformat, it doesn't get rid of this new line here, but whatever. So now that I've parsed all the rows, I hope, I'm going to say... Actually, can I just, like... Do I iterate over this? I guess that's fine, although... Really, what I should do is go back to streaming now that I am doing what I meant to and say for each ordered it's a list of pair. Actually, can I not... I have a list of lists, but I don't really need that structure, right? I could just have a list of pairs. So how do you, like... You know what? Get the stream shit out of here. Can cat? Is that a thing you can do? I mean, what do I have? Flatten? Yeah, this will return a list of pair, right? An iterable of iterables to just an iterable. This is what I want because... Or no, wait. Idiot, just say flat map. Right? This is actually legal. And now we get out... So I could have streamed after all. Oh, but now it doesn't know about... Okay, never mind. I'll stick with the Kotlin types. You got me. Let's iterate over a list of pairs of instant chars. Create destructuring declaration? Cool. Index and label. Wait, what? It's iterating. Oh, God. For index label in input.filter of that, do this. Oh, that looks pretty bad. Like this. For each index label. Is this allowed? This looks allowed. This is a lambda. Yeah, okay. So now I just want to say stacks of index dot add. That's not how you spell stacks. Add first of label. Right? I think that's right. And then I can just say, like, that's it, actually. That's the answer. I don't... Oh, I can say return. Everything's mismatching. Oh, yeah, no, I don't return that. I return the stacks. Great. And we can just say empty list here. We'll just return that. Oh, I have to say return. This is the thing I constantly get confused about in Kotlin, is when you have to say return. I think I understand it, like, abstractly, is when you are in the body of a function that is declared with an open brace, you must use return. When you're in the body of a function declared with an equals, you must not return. That's very simple, and I understand that. What tricks me is that when you're in the body of a lambda, you must never say return, even though it starts with an open brace and ends with a closed brace. So I don't totally understand why that distinction syntactically is there. Why can't I just, at the end of a function, not say return and, like, return and have empty list implicitly be returned? I don't understand that. There may be a good reason. I don't know what it is. So what I want to do here is just say print line of input, right? And, like, did we succeed at parsing all of the rows? It looks pretty good. QM... Oh, yeah, we can just compare this to the input, can't we? Yeah. So, QMGCL. Great. This is perfect. Let's take one at the end just to make sure we got the 9th one right, because being near the edge of this is a little weird, but ZFHG. Great. And there are no moves. So, fantastic. And so to parse moves is much simpler. I don't have to figure all this shit out. Or, I guess, this shit. I basically want to do something very similar and say, like, return input.filter move.match as, well, I can, like, flat map here, right? I think so. Flat map of val, get out of here. Yeah, so val, what was I calling this? Match equals move.match entire of it or else return to flat map an empty list. Why are you like lighting everything up here? What is wrong with you? What are you mad about? You're just okay. When I'm done writing, hopefully you'll figure all this out. Val quantity source destination equals match dot destructured. Get out of here. And then I'll just return a list of move. Is that the type I have? Right? Good. Move of quantity source destination. Right? Are we happy now? No, because I have to call to int. To int. To int. To int. Destination's a type? Oh, you tricked me when you auto-completed. I thought you knew what you were doing. Okay, and the warning we had there has gone away. Great. So, let's run this. Hang on. Return. Let's run this and see if we get it to print out some moves as well as the stack status. It printed a bunch of moves. You know, the last one is 5 from 3 to 9, right? Great, we did it. So I think we can celebrate by committing this. Day 5 parser. What is my one warning? Unused import directive. Yes, we did not import that on purpose. Thank you for the reminder. Cool. So maybe we can start solving the problem now? I mean, honestly, I think most of... Oh, don't alt-tab. Most of this advent of code, I feel like, was writing a parser. It's a pretty nasty input format, I think. As things go for a day 5, anyway. So, now we can say part 1 of the input, basically. Like, we have to implement part 1, of course, but... Part 1 of the input. Cool. Input, so, and this of course should be an int. No, actually it's a string this time. I forgot, we're actually using strings. So we basically say, let's iterate, let's, I guess we're iterating over input dot moves. Why would I need to destructure over this? I guess that's fine, actually. Yeah. Quantity source destination in the moves. Fantastic. mutation is going to trick me. It's very convenient right now to just modify the input stack, right? And that'll work fine. I'll get the right answer. But then I'll have screwed up the input for part 2. So I need to like copy all the stacks? How do you do that? Like, is that a thing that, does it have clone or? So array deck, it is clonable. Okay, presumably this works then. Does Kotlin have any weird interactions with clonable? Kotlin clone? Is that a thing? Do you clone an object? For data class, there's copy, but that's only a shallow copy. You just call clone. Okay. Fine. So, really, I should say input dot stacks dot map of it dot clone. No? Am I crazy? It's a double-ended queue, and we looked and it supports clone. You just told me that there's nothing special in Kotlin about, I mean, it's clonable. Now if we look for clone, we see it's right here, a copy of the queue. It's clone. Oh, it's because I'm using this fucking Kotlin deck instead of the Java one, isn't it? Oh. Give me the one in Java util, please. So it's got the wrong one here, too. I want to import this. Import it. No, I'm calling it array deck. You can't have that name, Kotlin. Right? Okay, cool. So now this one is the one in Java util. Thank you. And now, look at that! Clone. You can't stop me, Kotlin. So now I've cloned all this, and I want to call it stacks. I've cloned each of the input stacks, and those are going to be the stacks I'll actually modify. And we can just say, you know, how do you do something n times? And let's just see what happens if you say dot. Like, can you num times or something? Yeah. Oh no, this is actually multiplication. These are operators. Repeat? That was the thing we looked at earlier, isn't it? Yeah. Repeat quantity. Am I supposed to, like, write this? Is that how you do that? It is. Okay. So quantity times stacks of source plus 1 dot take, no, how do you, there's peak, I thought there would be take, poll, I guess. I mean, this has all sorts of concurrency stuff built in, which we don't need. All right. I'll just take poll last. And let's make sure... Where's the Java doc for this? Retrieves and removes the last element. Great. That's what I thought. So I've removed from the source, and I want to say, you know what? Let's actually do this in a different order since Kotlin lets us, right? Let's let moved. I guess just say, I don't even need to name it, right? Stacks of destination plus one dot offer last. How do I add last? Right, of course. Add last of it, right? So what we've done is use Kotlin. Like in Java, you might have to say, you know, okay, I'm taking something from poll last. I'm taking poll last from the source, and now assign that to a variable, and then, you know, say offer last or add last to the destination of that variable. And you could do that in Kotlin too, and they're fine. But it's kind of like, well, why does that variable really exist? You're only using it once, right? Couldn't you just inline it? And the problem is, if you inline it, you end up writing like stacks of destination plus one dot offer of stacks of source plus one dot poll, and the order you do things is the opposite of the order you wrote things, which is okay, but not ideal. And in Kotlin, there's always a few scope, like every object has some of these scope functions on it, like let, where you can say, okay, take the result of this call and let it. And I'm just going to call it here, but you could give it another name. And like, then you call a lambda, you give it a lambda and say, call this lambda with the result of what I did before. And so we get to say poll, let, add. So, I mean, I think this is like kind of done for part one, right? But what's the, what am I supposed to print? The top crates in order. Okay, cool. So easy enough. And then just say return stacks dot map of it dot first. Is that a thing I can do? Actually, I can probably just say it 0. No, it dot. Let's keep using these like queues, shall we? Poll last. That's the end we're treating as the top of the stack. And then can I like somehow join this or something? Join to string. I don't want any of these arguments. Hello? Oh, you guys weren't seeing that, were you? Whoops, I didn't switch back. I thought I did, though. Hello? Oh, I did. The problem was I alt-tabbed. Okay, got it. Now I have to switch this. Okay. Kotlin join collection string. There's join to string, but that's got all these dang... There's a million arguments. But I guess they're all optional? Oh, the default operators is just like... Sorry, let me just show you this. So So you can see it defaults to joining with comma space. I think I just want to say separator equals empty, and it should be fine. Dot join to string like this with separator equals empty. What happens if I just run this? Wouldn't this be exciting? Good, it's broken. Oh, I should be subtracting one, not adding one. Because my stacks are 0 indexed, but the instructions are 1 indexed. There you go. It's a bunch of letters. I love it. That's the right answer. Okay, thank goodness. Oh, you know what? Let's go commit that before we start reading. Anything here I don't want to commit? No, I don't think so. What the hell is going on over here? Couldn't fit that with this in the way, I guess? Okay. Day 5, part 1. Nope, don't Alt-Tab. Okay, crate. Pick up and move multiple crates at once. Yes, as I predicted. Moving 2, they stay in the same order. Yes, of course. After the rearrangement. So it's okay, it's the same thing. We just have to move things differently. So that's what I thought would happen, and it happened. So let's just say part 2, part 2. And rename this to part 2. And we just need a buffer is a stack of an array deck. I probably have to specify what type, don't I? I'm actually kind of shocked it doesn't complain that I haven't said what type it is. Oh, because stack knows, I told stack it's only for chars, so I don't need to specify the type for array deck because it knows it's being given to a stack. Fine. So we can just say quantity times pull last from the source, but instead of stacks destination -1, put it in the buffer. And then this time, instead of taking from source 1, take from, nope, the buffer, and put it here in the destination. And I think that's all we had to do. We'll find out, of course. Totally different letters. Let's see if it's right. It's right. Okay, great. So, beautiful. Kind of got exactly what I expected for the part 2. Not a big surprise. Anyone with a brain who was interested in trying to predict what the next part would be could see that's a reasonable thing it could be. Although you can't say for sure, of course. So, by far the hardest part, I think, was writing the parser because regexes are a nightmare. And I was, working with an unfamiliar collection library. But I don't think it turned out that badly. Let's Well, let's commit it, I guess, first of all. Part 2. And then just have a look over it and see, what do I think of this? Is there anything I should have done differently? Also, I'm a little surprised I only ever ended up needing array deck. I didn't need any other imports from whatever. I don't know. I guess Kotlin puts like the whole standard library. Obviously, there's stuff that isn't. I was going to say it puts the whole standard library like in your namespace or your whatever, in your imports automatically, right? Unlike Java, which kind of only puts stuff that it considers very core to the language there, and you have to import everything else. Anyway, but I didn't have to import much. Stack is an array deck of char. I think that makes sense. We defined a move and an input. That's good. We parsed. We ran part 1 and 2. Now, this, like, there's a lot of duplication here, right? It would be nice to factor this out somehow. So part 1 and part 2 could both just be calls to some other function where like the body of this for loop was a parameter. I don't yet know how first-class functions work in Kotlin, which may sound crazy. Haven't I been using them all over the place to like pass lambdas to things? But I haven't really. Like, I've been passing lambdas to things that say, you must pass me a lambda, and please do so in the last position. I've been using them like Ruby block arguments or whatever. I think in principle, you can just write like, you know, val x equals fun somehow. But I don't know, like this? Can I do that? Okay, return one. So like, yes, this is legal. You can create a lambda like so. And so you should be able to like return them. I assume I could say like x or, you know, f int or something. Return f. Yes, that's also legal. Sure. So I should be able to define a function that like does the operation and then pass it one lambda for part 1 and a different lambda for part 2. It's not actually so easy because part 2's lambda closes over this buffer that it needs to mutate. But I guess it's not that hard, right? I mean, it's not like this is going to be a short video anyway. I might as well try to play around with this, because this is something I would just do completely trivially in Haskell, and I would do all the time and consider, or closure, or whatever, and would consider a matter of good design, or, well, okay, maybe not good design. When n is 2, you don't have to really extract every bit of duplication you can, but it's at least a tool I want to have in my toolbox. So let's say we have a function run crane that takes an input. It's an input. And a function? How do you do that? Oh, let's say apply move, which is a function. Is that allowed? Can I write that? I got caps lock on again. It's like I have caps lock on my caps lock mapped to control at like the Windows registry level, I thought. But maybe I'm only doing it in some wrapper layer. And I have print screen mapped to caps lock in case of emergencies, and I somehow accidentally turn on caps lock anyway. So that I can turn it back off. So can I say fun of move, which is a move? Is that allowed? Like, how do you... Oh, I can't just show you that, can I? Gotta switch to there. Kotlin, declare lambda declare function as parameter. So here is what I found. Their first class, arguments to functions. Ah, okay. Like this? Weird. Why not just use fun? You already have that, but okay. Is this allowed? Yes. And this whole thing returns a string. So I think I could say, you know, here's my new stacks. And then say, oh, not ipnut, input dot moves. Let's iterate, but this time a single variable. Oh, I can't just take a move, right? I have to take a list of stack, I guess, right? We then call, oh, this has the same, let's call this apply move then. Apply move. Do I just do this? Yeah, I have to pass the parameters. Move stacks. And then say this, right? What are you mad? Oh, I didn't say. It says return. Yeah, okay. So now I think I could say for stack, for part 1, I could just say, oops, move stacks, no? Run crane, I called it? Bizarre, okay. Run crane of input and then like this, right? Lambda, I guess. No. Oh, this one should be called move. I see. It's a little messy in here. Just a sec. Lambda. But instead of move, I want to destructure it. Will you just like structuring declaration, thank you, to this. These should be called stacks. Right? So if I ran this, would I get the same answer? That looks about right. VCT whatever? Is that what I had before? Yeah. So this has successfully factored out some of the logic from part 1 into this helper, but I haven't done the complicated part, which is making part 2 work, right? However, it's not that bad. We basically just say, we create this buffer, and then we say, like this, right? Return this, but in the body, we write this instead, and then reformat. Right? GCF, I think that's right. Yeah, cool. So I like that. I might even go so far as to, nope, as to make this use single expression body instead of block body. But so here, this lambda that we're passing has some state that it's closed over, so it can mutate. It has this. I mean, I guess we don't even have to do that, right? We could make a new buffer every time. It's arguably even a little bit cleaner, because why should we reuse the existing buffer? And in fact, I could say, here's the quantity you should expect. Is this still the right answer? Yeah. Yeah, I mean, that's not bad, right? The parsing's not beautiful. That's not horrible. So let's just say day 5, factor out repetition from part 1 and part 2. All right, and let's end this marathon of an episode, shall we? Oh, I can't bear to look. How long was it? I can't even show you guys without... I can't even look without... Not okay, less than 2 hours. I mean, it could have been worse, right? Anyway, I hope you enjoyed. Thanks for watching, and I'll see you next time.